Hi, welcome back to Dr. VASU'S lectures. In continuation of our C programming, we are going to see the operators in C, the first part. Operators in C. So here we have different types of operators in C. They are arithmetic operations. We'll see what are the operators first, and then we'll go into the details of all of it. Relational operators, logical and bitwise operators, assignment operators, conditional, and miscellaneous. These are various types of operators we are going to see in C, right? So first, let us start with the arithmetic operations. So here we are going to do some mathematical operations, right? We are calling it as arithmetic operators. So mathematical operations we are going to perform. They are addition, subtraction, multiplication, division, and modulus operators. These are some of the mathematical functions we are going to do. And also an increment and a decrement. We'll see each one by one in detail. Before proceeding further, please like, share, and comment if you like these lectures. Please subscribe to Dr. VASU'S lectures, and you'll get many number of videos. All these are meticulously planned for your easy understanding, very easy remembering also. You can easily reproduce. Thank you. Okay, arithmetic operator, addition. Let us start with let us take a simple program and see how it is implemented. So if you take this program, in the printf statement, I have written the sum of given two numbers directly, and I want the result here. The result is the addition of 100 plus 25. I'm going to put this addition value here in this place. So complete the program, compile and execute. You'll get the sum of this is 100 and 25 is 125. So like this, actually we can also even write the addition, this type of operation here also in the printf statement. But the general way or the better way will be, we'll see. Suppose I have declared two integers a and b as integers here, and also c. C is equal to a plus b, the addition of these two numbers. A and b are given the values. So here I'm going to print this statement %i. In this place I'm going to get the value of a. In this place I'm going to get the value of b. And here the answer is c. Okay, here in this place answer. So if you compile and execute, you get the answer like this: 35 plus 20 is equal to 55. Because this addition has taken place here and you are carrying the value of c, it is printed here. Okay. Now, suppose in place of plus, I just put minus, a minus b, and this value also minus. So our answer will be 35 minus 20, that is 15. So this is subtraction. Multiplication. In the multiplication, we put a star symbol here, right? So a into b, a is multiplied with b and is put in c, is assigned to c. We are going to see the multiplication of these two numbers, 35 into 20, 700. So we get the answer. Next, let us see division. Right? Division, for a division operation, I have taken these numbers instead of integers. I have taken them as floats. Let us discuss all this. Why I have taken this as float, we'll discuss this later very clearly. For the time being, treat them as floats. The numbers are same, 35 and 20, but decimal places are taken. Now, C is equal to A by B. Now, A by B, that 35 by 20, I want the answer. So, if you see, I have taken this display float F. Because I have taken F, decimal places have come and 6 places are displayed. 6 decimal places are displayed for each. Okay. Now, suppose I want to indicate percent. This percent symbol is used for modulus. The remainder is indicated with the percent symbol. So the operation also takes place like this. Here again we have taken the integers, right? And C is equal to A modulus B. The modulus. This is for modulus symbol. So here C value is, in this case, it will be 15. We know that 21s are 20. So 35 minus 20, we get 15. So C is equal to 15 in this case, the remainder. Now, I want to display this symbol for modulus here. If I put percent %i, this is for in display of the value of an integer. Similarly here, wherever it is. But when you want to have this percent symbol in the display, use another percent symbol here. Okay. Let us see how the display will be. 35 modulus 20 is 15. So to get this symbol in the display, we need to use like this. We are going to discuss all this again also, but for the time being, remember it like this. So to indicate this symbol, you need another percent symbol is to be used. So the display will be like this. So this is the modulus, the remainder. Okay, next. Increment operator. Next we are going to see the increment operator. Increment means addition of 1. Addition of 1 is called increment, right? So I have taken an integer, n is equal to 10. The increment operator is indicated like this. Is shown plus n. The actual meaning of it is n is equal to n minus 1. This is a comment. Just for your understanding, we have written in the form of a comment. So this comment shows the actual meaning of this plus n. That is, n is equal to n plus 1. N is added with 1 and is assigned to n itself. This is the meaning of it. So this is called increment operator. Now we are going to display what will be the, after writing this statement, increment operator, what will be the value of n. I'm going to show it here. Okay. So compile this and execute. You get now n is equal to 11. Why? Because actual value is 10. N is equal to 10 we have taken. 10 plus 1, 11. When it has become 11, it is assigned to the n here. So n is carrying 11, not 10. Its value is incremented. So the incremented value is carried here. That's the meaning of this increment operator. So you need to be careful and use it meticulously. Decrement operator. Right. The decrement operator is shown with two minus signs, minus n. Right? Minus 2 signs, as we have seen 2 plus signs in the earlier. Now 2 minus signs are displayed here and n. The actual meaning of it is n is equal to n minus 1. 1 is decremented. 1 decremented here. The meaning is actual value of n is 10. 10 minus 1, 9. 9, the n value has become 9 here. Let us see. So it is called decrement operator. Print the value of n here in this place. We'll see now n is equal to 9 because it is decremented, decreased by 1. Clear? Next. Next comes the relational operators. The relation means we know we have human relations. Relation in the sense, relation between two people, right? We call it as a relation. Similarly, here, relation between two numbers or two values, how they are. If one is bigger, one is smaller, or both are equal, both are not equal, which one is bigger, something like that. So the relation between two values is indicated by these operators. So the operators are, we all know this, right? Less than, x less than y, right? Or greater than, c is greater than d, like this, equal to. Both here, Earlier, we have seen 1 equal to sign. Now you are using 2 equal to signs. If you use A is equal to B here in programming, C programming, if I say A is equal to B, only 1 equal to symbol, the meaning of it is the value of B is assigned to A. But here when you use 2 equal to signs, the meaning of it is you are comparing this A and B. If A and B both are equal, this says yes or true or correct. If these two values, suppose A is 5, B is 5, then this gives out a result like it is correct. Say it says correct or true. Let us see how it is implemented. Similarly, not equal to symbol, right? This is these two when used here. This is the for not equal to. A and B are not equal to are used. Greater than or equal to, both. Here we have only one condition, greater, but here greater or equal. Similarly, less than or equal to, right? Two conditions. Now let us see each in detail with the help of a simple program. Less than symbol, how it is used. If else, so here we are going to see if else program in the programming. If something is happening, what happens? If it is not happening, what happens? That is, if it is raining, you need to carry an umbrella, right? That condition, if something is happening, we need to do something. Otherwise, we have to do something else. That if else is indicated here, and now we are going to see how it is implemented, how we are going to use them in the programming. So, if you see this, I am declaring A as integer, right? Enter any number. We are asking, we are going to display this one. Enter any number less than 100. I'm asking, we have given a condition that you enter a number less than 100. It reads and assigns that value, whatever you have entered, to A. This is the scanf. To read and assign that value to A. Now, we are going to compare that because I told that you enter a value less than 100. If this value of A is less than 100, then do this. What? Display the number is less than 100. That's fine. Suppose you have not entered that number less than 100 and you entered greater, some 200 or 300. What happens? Else. If this is not happening, you do this. What? Printer, invalid data. You can say it's a bigger number or something else or something else. Here I am saying it is invalid because it is not meeting my condition. Right? Next. Complete the program and compile it and execute. We'll see the output. It is asking enter any number less than 100. We enter a number, say 50. Right? It is correct. So what it says, the number is less than 100. This condition is met. This condition is met. So it is showing this. Now, suppose we run the program again. Enter any number less than 100, same. But I have entered a bigger number. What happens? When it is not meeting, when it is not satisfied, it does something else. What is it is? Invalid data. It has to say that it is invalid. Clear? So whatever you write here, it appears. It is, you can say it is a bigger value or something like that. So it is saying invalid data. So this is the way of utilizing if-else conditions statements, right? Now, let us apply this to greater than, right? Now, it's asking for a number, enter a number greater than 10. That value is assigned to A, and we are going to compare that number with the 10. The number is, if this condition is satisfied, this is going to happen. What? Number is greater than 10. If it is not happening, that is, if it is saying no, no, the number is not greater than 10, then this condition happens. This thing happens. It is going to say that it is invalid. Let us see what happens. It is asking enter a number and also saying it must be greater than 10. Suppose I entered 200 or maybe 11 or 100 through 200, 2000, bigger number. What says? The number is greater than 10. The number is greater than 10. Okay, next. Run the same program again. It is asking, let us enter 5. Smaller number I have added. What it says? It is against this condition, right? It is not greater than 10. So it is saying it is invalid, right? So that's how you will be utilizing this if-else condition in comparing. Okay, next. Let us see how this equal to happens. We are asking enter 0. It is displaying to enter 0 only. Okay, and it is assigned to A. Next, if A is equal to 0, right? The number we have entered, if it is 0, 2 equal to signs are used. Please observe 2 equal to. That means if A and this number are compared, if these two are equal, it results in thus this statement is true, right? If it is correct, then do this. What number? It says the number is 0. Fine. If it is not, what happens? Else. Do this. What? It says invalid data. Okay. Now, let us see. It is saying compile and run it. Enter 0. Suppose I entered 5. Some number. What happens? Invalid data. It is asking for 0. But you entered something else. So, it says invalid. Next. Compile it and run again. Now, I have entered a negative value instead of positive, instead of 0. So, minus 50. Again, it is not meeting this condition. So, invalid. Run it again. I entered 0. It is meeting. It is satisfying this condition. So, what it should say? The number is 0. Yes, the number is 0. You are satisfying the condition. That's how it works. Next, not equal to. How this not equal to functions? It is asking for enter any number, right? The same program, it is assigned to A with the scanf function. If A is not equal to 0, this symbol indicates these two are not equal. If these two are not equal, it results in some condition called true. It is saying correct or true. Now what happens? It is some number. If A is not equal to 0, something else. It may be minus 10, minus 100, plus 100, plus 200, something else. It is some number. Else, it is 0. It has to say that. Clear? No. It is asking, enter any number. We entered some positive value. It says, it is some number. It doesn't know, but it is not 0. Next, enter any number. Entered negative number. Again, it is not, it is some number. It is not the number which it is asking. Right. Enter any number. 0. It is satisfying this condition. Right. It is not equal to 0. That means this condition is false. That's why this is not happening. What happens? Otherwise, do this one. So it happens. So this condition is met. It is saying it is 0. Right. So that's how we'll be utilizing this equal to and not equal to symbols, operators. Now we are going to see less than or equal to, both. Earlier we have seen only less than. Now we are going to see less than or equal to, right? Enter 0 or negative number. It is saying either number 0 or negative, and assign that value to A. if A is less than or equal to 0, do this. What? It should say it is either 0 or negative value. Otherwise, invalid. Okay. Now, compile and run. Enter 0 or negative. It is saying clearly, but I entered a positive value, a bigger value, right? 100. What happens? This condition is not met. This condition is not satisfied. So this is not happening. So it is saying something else. So invalid. Clear? Next. Again execute. -11. I have given negative number. No. What say? This condition is satisfied. It is less than 0. Negative. So it is satisfied. So this is showing this condition. It is either, it must be 0 or negative. Clear? Now, compile it again. Run. I entered 0 now. It says either 0 or negative. Either it must be 0 or a negative number. So it is, this condition is satisfied. So like this, less than or equal to symbols are used. Next, greater than or equal to. Greater than or equal to, same, it is asking for 0 or positive number. Assign that value to A. And if A is greater than or equal to 0, it says, that means if it is positive or 0, it should say that. Otherwise, it says invalid. Now, enter 0 or positive value. It is, suppose I entered 45, a positive number. It says either it must be 0 or positive. Compile again and run and enter 0. It says it must be 0 or negative or positive. Next, I entered a negative number, right? For the same problem, I entered a negative value, -10. Invalid. It is not 0, not even positive. That's why it is invalid. Next. So these are all about, we have seen some arithmetic operations, right? And also relational operations so far. And in extension of this, we are going to see arithmetic operations in the next part. If you like this, please subscribe to Dr. VASU'S lectures. Thank you.